I'm going to cut the fence for the miter saw. So one side will have only very short piece, just to allow me adding some clamps and maybe small short stop blocks, and the other piece will be 4 feet, which is 122 centimeters, and I'm going to lubricate. So let's have a look at the quality of the cut. It's really clean. So now you can see how important it is to lubricate aluminum. Cutting the T-track that will be screwed to the top of the miter saw fence. Okay, again the cut is very clean thanks to generous lubrication. This is actually fence which is intended to be used for the mobile miter saw. When you have the proper miter saw station, you don't need this solution. This solution is for the mobile miter saw when you want to take it with you to the site, to the customer site, to the construction site. So first of all, I will have two parts. One part will be on the left and the long part will be on the right. Now I want to attach the spacer, which is 1/2 inch plywood and the 3mm aluminum sheet, because that spacer gives me exactly the proper height between the slot and the holes, which are pre-drilled in my DeWalt miter saw. So what we need to do now is to drill the holes in the spacer that allow me to attach the spacer to my aluminum extrusion. So now I clamped the aluminum to the plywood and I can drill the first hole using my self-centering jig. It looks perfectly centered. So now I will put the bolt here to lock this. Okay. Now I can clamp it here. Looks good. And here I will use my jig again. Yep. Okay, this time we are very clean because we used the backup piece of wood. So I will put the bolt here to lock it in place. Just a small reminder to those who didn't see my video how I was making this self-centering drill guide or self-centering dowel jig. If we put it this way, the drill bit will make it fly. So we have to do it this way, because as it rotates to the right, it will lock on the edges. I'm using cobalt 5% drill bit for aluminum or even iron and stainless steel. It's really it's quite expensive, but it saves you a lot in the long run. So let's start with this one. Okay, perfect. Okay, I could slide it from the end, but I want to show you that and they are specifically designed so that you can insert these T-nuts from anywhere. So that's why these slots are perfect. You can see they went in seamlessly. So now I will just tighten it. Okay, and now this one. Now I'm using my left hand. It's a good habit to practice working with both hands so that you can become ambidextrous. Right, so it feels good. It's not flush, as I mentioned. I have to flush trim this with the flush trim bit. I'm using Triton router, which I believe is the best choice for the router table. So it allows installing the bit over the tabletop. It locks itself when it's in this position. Okay, so now what I have to do is to tighten it, and we lower the bit, and now you can see it can already freely rotate. Okay, so here is the aluminum extrusion with the 1/2-inch plywood spacer and 3mm aluminum bottom to make it durable. So I want to flush trim this bottom part to be flush with the extrusion. So I will be riding the bearing, and this is called bottom bearing even though it looks like it's on top. So I'm going to lower it, so just in case we don't damage the extrusion. I will lower it all the way. So I'm going to lock the router in this position. Looks like we are perfectly flush. Here's the quality of the cut. Looks very good. This time I'm using the 60 teeth construction grade blade, and it's doing very well with aluminum as well. So you don't have to use specialized blades. It's looking good, nice and clean, beautiful cut. So now I can actually demonstrate how this fence will work. This short piece will be here. It will be clamped using these pre-drilled holes that came from the factory. As you can see, they align with the slot of the aluminum extrusion thanks to the spacer and 1/2-inch spacer and 3mm aluminum sheet. So I will slide the head of the bolt coming through this hole into the aluminum extrusion slot, and it will hold this aluminum tight against the factory fence. And the long fence will work exactly the same way. It will clamp to the original factory fence, and it will allow me clamping the various jigs and clamps to these extrusions. So it will also allow me cutting small pieces and clamping small pieces to the table and so on and so forth. Okay, so this is the front, and now I will assemble the small piece. Okay, now I will put the bolts from the back and screw the T-nuts for the slot. Okay, so now the black bolt comes in from the back of the factory fence. Then I put the T-nut on the bolt, and now I slide our upgraded fans on the slots. And I can finally tighten the bolts at the back, which is pulling the T-nut inside the slot, and the fence is nice and solid, it's not going to move. Okay, let's tighten the other side and we will be done. Done. I'm going to make the very simple yet very nicely designed clamp for my miter saw or any fence that is using T-track. And the idea is I will use this 3/8 by 3/4 inch square or rectangular aluminum stock. I will cut it to around 2 inches, maybe 2.5 inches. Then I will drill M5 and I will tap it to M6 so that I can attach it to the fence, and I will also drill it to M7 and tap it to M8 so that I can use this long bolt as a clamping mechanism. To drill the holes, I will be using my self-centering drill guide or self-centering doweling jig. The first thing I want to drill is the T-track slider. It's okay, I'm going to cut on the right side of this line. Okay, since we are already at the drilling station on the floor, let's drill the 3/8 by 3/4, 3/8 by 3/4 inch rectangular bar stock, and it fits perfectly into the T-track, as you can see. So I can again use my self-centering drill guide. One hole I want to be in the middle of this. Let me mark it on 15, and the center will be determined by self-centering jig. We made it all the way through. I purposely made it long enough to be supported by the T-track. So I think I'm going to make it 60 mm. So the M7 hole should be on 45 mm. We don't need to mark the center because it's going to self-center. So again I will place this 3/4 inch stock inside my T-track because it fits perfectly. So the hole is started, we don't need the jig anymore. I'm using cobalt 5% drill bit, which makes it a piece of cake for drilling aluminum. Okay, now I'm going to tap it. So M8, we put some lubrication. I'm using spiral bit, which is suitable for aluminum because it's expunging the waste upwards and it's not clogging, even though this is a through hole, and spiral bit is performing very well on the blind holes as well. Okay, it feels like we are all the way through. So let's unwind it. So as you can see, the cut is nice and clean. For lubrication I use car engine oil because that's what I have on hand. So now that we have this piece, I'm going to cut the slider for the T-track. You can see that the cut quality is very good. Okay, so now that the slider is where it belongs, which is in the T-track, let's bolt them together. For now I'm using the grab screw because I don't have the knob. I'm using the bolt, which I cut to 1/2 inch length. The threaded part is 1/2 inch or 12.5, 12.7 mm. So this bolt we put from the back of the original factory fence. So now I'm putting the M6 T-nut that will be sliding inside the extrusion. I'm pushing the extrusion fence that we made towards the factory fence, and I'm tightening these bolts and the other one as well. Okay, done. I intentionally designed it this way that the fence on one side is much longer and the other side is very short. So this allows me cutting longer pieces and using the stop block on the longer piece. And for precision work I can use mostly the short fence. So let me slide it in again. As you can see, here is the T-nut. I'm sliding it into the extrusion. Now I will tighten the bolts at the back. So the same drill, I'm pushing my extrusion fence to the factory fence while tightening this 1/2 inch bolt, and I can feel it's already nice and tight. Okay, and now we can tighten the second one while pushing the extrusion to the original fence. Okay, done. Side, and the left side is short. The left side is 270 mm and this one is almost 1000. So the first cut will give us the zero clearance insert. That's why I put this sacrificial 1/2 inch plywood. On the first cut I will make the zero clearance slot. Okay, now I'm going to make the stop block, which is meant to be universal. So it has to work on the left side of the fence, on the right side of the fence, and also on the miter gauge and table saw fence. That's why I'm going to mark where I need the holes to be, and then I will drill 2 holes and file the slot to accommodate all the positions, all the heights required for the stop block screws or bolts. So let's drill the hole. Okay, so here is the stop block with the slot, and here will be our knob. I need the slider to be put inside the extrusion. Because I don't have it, I'm going to make it. And now I'm going to cut it. So there you have it. Let's test if it fits. Okay, perfect. So now what I have to do, I will drill the M5 and tap it to M6, and then our stop block should be functional. Okay. This is M6. Okay, that was easy. So now I can straight away test it with the M6 stainless steel knob, and it fits very well. So we should be good to go. So let's assemble the stop block. Okay, so here is our stop block that can move freely, whether we have the zero clearance platform or whether we are using factory table. There is a slot that allows us to adjust the height of the stop block, so we can use either slot on the left side or on the right side. So we are really set and ready to go. You can see the cut is very, very precise. Let me check. Square, perfectly square. It did not fully satisfy me with this aluminum peg. So let's mark stainless steel bar, which is 2.5 millimeters thick and 3/4 inch wide. So now I need to drill the hole in the aluminum. There we go. Here is the matching aluminum hole. Okay, now I'm going to cut the spacer. It's getting very hot. Okay, so let's test it with the M5 bolt. So let's assemble. So we will put the spacer on the M5 bolt. Okay, so the second spacer is in, as you can see. So now we will put this aluminum piece on the M5 bolts, and they will be holding everything together. Okay, now I'm going to tap it to M8 using the spiral bit. Okay, so now let me try M8 bolt. So as you can see, we have a nice aluminum peg. It will be going in this way, and then we will be tightening it here, and this aluminum holder will be separating this M8 bolt and holding everything together. So what I need to do now is to drill M8 or M9 hole in this aluminum. Let's drill the holes in the aluminum holders. The M8 bolt goes through the hole in the aluminum holder, and it has to thread onto this peg. Okay, always remember about the safety. Cut is nice and clean. This is called compound bevel hacksaw. Okay. Okay, cool. Check it out. Okay, done. Now I'm going to drill it with the M5. And once we tighten this one to the base and this piece to this piece, then it will be holding the fence and preventing it from moving up and down. I'm going to tap the holes in the base to M6. I didn't drill these holes, they were already there, they were pre-drilled by the factory. It's quite loose because this is not solid, but it should be fine. I'm tapping with M6. I countersunk this piece that will be permanently a fixture to my base that is also not moving. This base is stationary and this will be constant permanent fixture. This ½ inch and this 3/8 of an inch are perfectly flush with this part of the fence. So I'm hoping that as I screw that in, this fence will be no longer moving up and down, because this is our problem. So finally I made the countersink a bit deeper, so it's flush, even though it's not really important. Now the fence, the factory fence, it's always moving up and down. Even when we tighten it with the black knob, you can still move it. So in order to achieve our new extrusion fence clamping capability, we need to immobilize this factory fence. And how I achieved that was by adding ½ inch aluminum block, which I filed to not to obstruct any movement, and then 3/8 of an inch piece is flush with this ridge, with this shelf, and the ½ inch block. So now I also drilled through the hole with the 1/4 inch drill bit, which is slightly bigger than M6, which allows M6 to freely go in and out. So now I will simply put this knob in, tighten the little block, and voila! The fence doesn't move at all. So now we can clamp small pieces using the external extrusion fence. Yes! Finally! So when I don't need this, I can move it out of the way. I can move the fence as I want. When I need the clamping capabilities for the external extrusion fence, I just tighten this aluminum block, and yes! So we have the T-track, we have the sliding bit and the clamp top bit with the sink, and it looks like it's perfectly matching our requirements. Now I can tighten it by hand, and it's solid like a rock. So that we can also move it out of the way. Okay, and we can remove it. We can easily slide it in and move around our extrusion fence. Okay, so now we have 6.35 mm, which is 1/4 of an inch hole with no thread. Then the M6 bolt is slightly smaller than the hole, so it can move in and out very easily. And we have the sink here that allows the anchor bolt, which is 14 mm, to sink in this piece, and it also makes it look better. And then the sliding bit threads onto the bolt, and we can put it onto the T-track, and it's almost functional now. Okay, it's time to start putting everything together. Here is my zero clearance insert. The machine is off. Just want to align it with the blade. Okay, that should be correct alignment. Let's put this part of the clamp into the T-track. Okay, I decided to round the corners of both pieces at the same time. Now let's slide in the longer fence. So I'm pushing the fence downwards and towards the factory fence, and I tighten the bolt, and now it's firm. So let me show you why we had to go through all this hassle of making these fixtures. If we didn't make this fixture, even though the factory fence is tight, it can move up and down about 4 millimeters. So we could not use this fence for clamping purposes. And now that we made this little baby, I can rotate the 3/8 of an inch piece, which is sitting on top of the 1/2 inch piece. I can tighten it, and now this fence is solid as a rock. You can see I cannot even move it. So have a look now. I put the long fence on the right side and the short fence on the left. Both fences are held in place and cannot move up and down anymore, thanks to our patent, thanks to our hack or fixture. We will proceed to fixing our mini clamps. Okay, so let's assemble our mini clamp. We will start from threading M8 into the 3/8 of an inch aluminum block, and here we have the foot which I still haven't decided whether I want to use a wooden foot or rubber or cork. And here is the peg with the threaded M8 hole. Put the bolt into the peg. Yep. Okay. So the peg is in. So let's slide it into the T-track. Okay. Let's tighten the mini clamp to the T-track by hand using the anchor bolt. It's more than enough. And here is our mini clamp. We are going to use our mini clamp to make some cuts. Let's say I just want to trim the end to make it square. Let's do that. So I'm going to connect the machine and make the first cut. I'm going to put some lubrication and let's go. I have safety glasses. So let's examine the quality of the cut. There you have it. Very, very beautiful. Okay, so now let's make the peg, which is ½ inch long. Because we have XPS system in place, the shadow is telling us exactly where the cut would be, so we can see where you will be cutting. It is hot, but look at that, the quality of the cut is basically perfect. Now you are starting to see the benefits of mini clamp, because the material is held very firmly, it's not going to move. So I call this a gate system. I made the same patent or the same design for my ultimate bar clamps for the glue ups. So here is our stop block. I'm putting in the slider into the extrusions slot. Okay, done. You can see I can flip the stop block around depending on which side of the fence I'm working on. So let's say we want to use the stop block to evaluate the cut length. Let's say I want to follow that one, so I can use existing piece to adjust the stop block, and then I can tighten it here. So the stop block is not going anywhere, it's firm and tight. And we can use our stop block as well as the clamp to cut our material precisely. So let me make one more cut with the stop block, tightening it by hand, and it really is sufficient. We have the clamp in place, we have the stop block in place. I lubricate the piece. This is the ultimate test and the final clip for this video that demonstrates the extrusion fence, the mini clamp and the stop block, which is allowing us to cut precisely small pieces. Safety glasses always. Right, here's the piece. Looks really beautiful. Both ends perfectly flat. You can see it here. Really nice cuts, precision. So thank you very much for watching. I believe this is a really interesting video. The project is successful. We have the mini clamps, we have the extrusion fans that doesn't move up and down. We didn't have to modify the factory base too much. The only thing that we had to do was to tap the M6 hole at the back, and we didn't have to drill any additional holes to create the setup like this. We have the stop block, which works both with the zero clearance platform and without zero clearance platform. In fact, I'm going to remove the zero clearance platform now. Okay, so here's our round stock. You can see it's really 90 degrees. You can see that here. So now I will remove the zero clearance platform, and voila. So the stop block is moved to the lower slot. It works very well. Right, so thank you very much for watching. Please don't forget to subscribe to Tiger Carpenter and stay tuned for the next videos, because there is a lot of interesting stuff coming up. Once again, thank you so much for watching. See you again. Bye bye. Okay, and the final part of assembly, which I forgot about, was putting the nuts on these stilts.